Hello everyone, and welcome to the VMware vSphere Design 101 webinar presented by Scott Lowe. I'm Chris Mogget from TrainSignal, and I'd like to take a minute to tell you what to expect in the next hour. First, I'd like to draw your attention to the questions box in your webinar control panel. Scott will be answering questions today, so please feel free to submit your questions during the presentation. Also, if you have any technical difficulties, let us know in the questions box, and we'll do our best to assist you. Today's presentation will be recorded and available to view on our blog. We'll email you the link after the presentation. After you exit the webinar, you will be prompted to take a short survey. TrainSignal wants to hear from you, so please take a few minutes to complete the survey. We'll also be choosing one participant from today's audience to receive a copy of our training, Designing VMware Infrastructure by Scott Lowe. To be eligible to win, you must complete the survey that you will receive after the webinar. Be sure to fill it out. It only takes a few seconds. If you have additional comments or feedback, you can also email us at webinars@trainsignal.com. And with that, thank you for joining us for today's webinar. And here's Scott Lowe.
Thank you. I appreciate it. And thank you all for joining us today. I hope that over the next hour or so, we're able to share some information that is helpful and useful to you. Our topic, as we mentioned today, is titled VMware vSphere Design 101. And what we're going to be doing is giving people an introduction to what vSphere design is all about. So what are we going to cover in this webinar? Well, we're going to start out with an introduction of what vSphere design is. Then from there, we're going to move into some basics of design. What are some of the common things that need to happen and some of the tasks and procedures and processes that you need to follow? After that, I'd like to talk about some common design misconceptions. And then I'd like to wrap up the webinar with a look at whether or not pursuing VMware certification, specifically the VMware Certified Advanced Professional Certification, is something that is a right fit for you. So let's jump right in. If you were to look up in the dictionary what the term design means, the dictionary defines the word design as to decide upon the look and functioning of something like a building or a garment or another object, typically by making a detailed drawing of it. Now, if you've ever gone and done any sort of design, IT architecture design, whether it be vSphere related or not, you know that a lot of times we end up with some very detailed drawings. But a design is more than just a drawing. A design has to encompass all the different areas that are affected when you implement something like VMware vSphere in your environment. So if we take that definition and we put it in the context of VMware vSphere design, what that means is that design is determining the function or appearance or architecture of a vSphere implementation so that it does what it's supposed to do, so that it functions properly within a given environment. And every environment can be different, so that function of what it's supposed to do is going to be specific to the environment where you're putting it in. We're making that design do what it needs to do in that particular environment. Your environment might mean it needs to run a bunch of web servers because it's a front end for a web server farm. Your design might mean that it needs to, or your environment might mean that the vSphere design needs to run a variety of workloads. Maybe it's virtual desktops, maybe it's server consolidation. In any case, all of these things, these are the functions that the design has to accomplish. And so when you go about creating and crafting a vSphere design, your role and your responsibility is to make sure that that design has the ability to fulfill the needs that the company has for implementing vSphere. It has to do what it needs to do. It has to provide that functionality the company's looking for. Now that's a pretty broad definition. It's kind of vague if we say it needs to do what it needs to do. That's great, but there's a lot of different tasks and perspectives and other information that are rolled up into what it means to be doing vSphere design. So let's shift our focus now from what vSphere design is and take a look at some of the things that are involved in vSphere design. So as I see it, there are some basics that are involved in design, and these are kind of the rudimentary getting started pieces. But what you need to do is you need to start out with a thorough understanding of what I call the design factors. These are the things that lead the design to where it's supposed to go. And there are 4 design factors. There are your requirements, your risks, your constraints, and your assumptions. And these factors each will influence the design in a variety of ways. Requirements are pretty self-explanatory. They are the things that the design is required to provide or to do. And you can look at requirements as being functional. It has to be able to run X number of virtual machines, or it can be a non-functional requirement. It has to be built in a certain way. These are requirements. You have to fulfill the requirements. Your constraints are another word we can use for the non-functional requirements. These are ways that the design is constrained, or your choices about the design are constrained. You have to use vendor X, or you have to build it in a certain way. You're constrained. A risk is anything, as the name implies, that presents a potential danger to the implementation of the environment, whether it be a lack of training for the staff, whether it be conflict between requirements and constraints, whether it be something else that just says, you know, there's a potential problem here in this implementation, we have to address the risk. And then an assumption is anywhere where the information is incomplete. Perhaps your customer or your own organization says, hey, we want our vSphere environment to be able to sustain future growth, but they don't tell you what that growth is. Well, you can't exactly design for growth if you don't know what that growth amount needs to be. So you have to put in an assumption. You have to say, okay, I'm going to build this design around the assumption that we're going to grow a certain percentage over a certain period of time. Or maybe you'll define what that growth means, X number of VMs and X number of years, whatever. And that's an assumption because it wasn't given to you. You had to fill that information in. Once you have this thorough understanding of the design factors, and the reason I say that you have to have a thorough understanding of the design factors is because if you don't really understand what the design factors are, you're not really going to be able to shape the design in the way that the factors require it to be shaped. So it's important that you really understand what the design factors are and have a complete and comprehensive understanding of that. From there, you're going to want to make sure that you have a deep knowledge of your current environment. Now, current environment can mean 2 things. Current environment can mean what you are getting ready to transfer into the virtualized environment. So maybe you have an existing non-virtualized data center, and you are going to convert those workloads into these virtual machines running on VMware vSphere. You need to have a deep understanding and a deep knowledge of those current workloads. You need to know what operating systems you're running, what are the configurations, and how much resources are being consumed by these workloads, and you know, what are the dependencies, upstream and downstream dependencies for these various workloads, and what are the relationships between them, and which applications and services depend on which others, you know, which ones are critical to the business, which ones have to be have certain levels of availability or certain SLAs attached to them. All of this stuff, not just technical, but also business related. You have to have an idea of what the current environment looks like, and you have to have an idea what the current environment looks like from an operational perspective. That's if you have an existing set of workloads. But what if this is a brand new implementation and you don't have any new workloads? What we would call in some spaces in the IT environment, we call this a greenfield implementation. Well, you still have to be able to articulate and describe what sort of workloads you're going to deploy on there. And if you don't have any idea what sort of workloads you're going to run, well, that's where we have to plug in some assumptions. And you have to say, we're going to assume that the average workload is going to be, you know, X amount of CPU capacity and X amount of RAM and X amount of storage space. And then you can build your design around that. But you have to have that deep knowledge of the current environment. There's a variety of ways you can do that. There are all kinds of assessment tools that'll gather that information for you. You can review inventory information. You can interview the current people that are in the environment. If this isn't your organization, but you're doing this on behalf of an organization architecting for somebody else, there's a lot of different ways, but you want to make sure that you have this deep understanding and deep knowledge of the current environment or the workloads that are going to be moved onto your vSphere environment. From there, you'll want to go ahead and begin creating the design. And this last phrase here is critically important in my view. and that is that as you create the design, you have to maintain a holistic view. Holistic means that you are viewing the design as one large entity, not as a series of smaller entities. A lot of times when we look at designing IT systems, we forget the systems part of that, and we focus too much on the components, and that is, we might say, I'm going to design storage, and I'm going to design networking, and I'm going to design compute, and I'm going to look at security, and I'm going to look at operations, but we look at all of these separately, when the reality of it is that all of these areas are intricately interrelated with one another. And it's really impossible to design one without also considering how others will affect that and how that will affect others. So as you create the design, you want to make sure that you are maintaining this holistic view. You want to make sure that you understand that a configuration change or a design change in the server platform that you're going to use will have an effect on networking. It will have an effect on storage. It will have an effect on your virtualized infrastructure, how vCenter is set up and how the VMs are configured, and so on and so forth. There's all of these relationships, all of these dependencies that are intricately interwoven among all the different components. So we really need to make sure that we maintain a systems view. We have to look at the whole thing as a system. Now, I noticed a question came in about determining differences between requirements and constraints, and I want to go ahead and address that before we move on so that we don't lose track of our thought processes here. So requirements and constraints, one way of looking at constraints is that constraints can also be described as non-functional requirements, and that is they are specific things that we have to fulfill, but they don't describe the function of the design that we're putting in. So let me give you a couple of examples. A functional requirement might be something like the vSphere design must be capable of supporting 250 workloads. That describes the function, and it specifies a requirement from a functional perspective. We have to make sure that this design is capable of supporting 250 VMs. And of course, I'm just making up these numbers, right? They would be determined on the information that you have based on your knowledge of the current environment and what you're trying to accomplish. A non-functional requirement, on the other hand, would say something like the design will use fiber channel for its storage connectivity protocol. It doesn't affect the function. I can build a functional vSphere environment using NFS or iSCSI or local storage for that matter, depending on the requirements. But this requirement says I have to use fiber channel. That's a non-functional requirement. It's also can be called a constraint. So really, non-functional requirements and constraints are kind of the same thing, and they constrain or provide a specific thing that you have to fulfill that isn't related to the function of the design. So I hope that helps distinguish the difference between requirements and constraints. They are related. They can be similar at times. And the way to distinguish between them is whether they affect the function of the design or whether they are just affecting how you go about satisfying the function of the design. By the way, feel free to keep questions flowing in. Happy to address questions as we go through the webinar. All right, so we start out with a thorough understanding of the design factors, requirements, constraints, risks, and assumptions. We make sure that we have a deep knowledge of the current environment, so we perform assessments on our current workloads. We gather extensive and comprehensive information about the workloads and the resources that they are consuming. We then move forward with creating the design, and as we create the design, we're going to maintain this holistic view of the design. We're going to ensure that we look at the design from all aspects and understand that all the different components and separate technologies that are rolled up in a VMware vSphere design, they're all interrelated with one another. And we can't change one area. Generally speaking, we can't change one area without having an effect or an impact on another area. And we need to be able to adequately describe and understand the impacts that occur. After we've created the design, we then need to make sure that we test the design to ensure that it does what it's supposed to do. And so there is a series of functional testing and operational testing that needs to follow the design to ensure that it meets the appropriate levels of availability, that it provides the appropriate performance levels that have been specified in the requirements, that it meets all of the functional requirements. Does it support the workloads that were specified that it had to support? Can it scale, as far as we can tell, to the levels that are required for it to be able to scale? Did it meet the non-functional requirements? Did it use the components that were specified in your constraints? Does it interact with the operational aspect of the organization in the way that it was supposed to, such as a certain team being responsible for a certain task or something of that nature? Then we have to test all this, and then if there are any points at which the testing points out that the design is not meeting the requirements in some fashion, if it's not able to sustain the growth, if it's not able to provide the performance that is required, then we have to go back, of course, and modify our design to account for that point at which we have fallen short. Now, this last step is very important. Now, naturally, between step 3 and step 4, there is another piece in here that I don't really describe, and that's the actual implementation of the design, right? Because we can't test it until it's actually been built. So you may have a pilot implementation or something of that nature, or a phase 1 early implementation where you're going to put this stuff in, and then you're going to run your functional testing and your operational acceptance testing to ensure that you have met your requirements. And then from there, if there are areas where the design is not satisfying the requirements, or if in the testing you uncover additional information that has to be rolled back in, then we go back and we revise the design, okay, and we make whatever changes are necessary, and we analyze those changes, again, with an idea towards keeping a holistic view of the design. We analyze those changes to determine what other impacts is that going to have on the design, what other areas are going to be affected, are those other affected areas going to be, or is it going to create changes that we also have to address? And if so, then how do we address those changes, so on and so forth. And then probably the piece that we really don't like, and that is document everything. We have to document everything, right? We have to describe the design from an architecture design perspective, and so we have to write comprehensive design documents that describe how the design was put together. We have to provide the details on what the design looked like. We have to draw the Visio diagrams that we see so commonly in the IT space. We have to incorporate the results of all of our functional testing. We have to describe what the testing was and what procedures we followed during the testing, what were the specific steps so the testing is reproducible and consistent. We have to provide operational guidelines. How do we go about operating the design that we just implemented? We have to provide a full-blown implementation guide that describes how we go about implementing the design that we've just created. It's not enough just to say, go install ESXi. We have to describe how ESXi is going to be installed, what are the procedures it's going to be used to install it, what are the tools and processes and kickstart scripts or auto-deploy configurations or whatever it is it's going to be that you're going to use. All of that has to be documented, and documented thoroughly, completely, and in great detail. Once you have all these 5 steps done, then you're going to proceed with the full-blown implementation if you haven't already been working on that, and that will be where you will actually go through and build the design that has been created, that you've crafted. Some of you on this webinar are probably going to be involved in both the design part of it as well as the implementation part of it. And there are also some of you on this webinar that may do only the design and then hand the implementation off to an implementation team. In either case, you know, the documentation that we create helps ensure a smooth handoff and a smooth transfer either between groups or between phases, between the design phase and the implementation phase. Any questions on this before we move on? I'll give everyone just a minute. If you have a question to submit, please go ahead and do so. All right. So, here comes in a question. See? The question is regarding disaster recovery planning during the design phase. So you absolutely have to include disaster recovery planning during your design phase. If I back the slides up just a minute here, and I build this out. So we talk about our design factors, and that would be the requirements and the risks and the constraints and the assumptions. Disaster recovery, RPO, RTO, SLAs, all that would be part of your design factors. So if you are aware, if the organization for which you're working or the organization for which you're doing the design knows when the design is put in that you're going to be doing disaster recovery, or knows within a reasonable time frame that you're going to put in some sort of DR solution, then you're going to want to be sure to incorporate that into the design. That will be a functional requirement that you have to incorporate, to say that the design must be able to support failover to X location, and then you'll have to describe the mechanisms that you're going to use to get data there, to handle the networking, what software packages will be included. Are you going to use Site Recovery Manager, or are you going to do your own scripting? What are the processes that the applications might have to follow? By the way, all of the work that you do in step 2, where you have a deep knowledge of the current environment, is critically important, not just for the vSphere design, but also for lots of other things. I run into lots of IT organizations that don't have a really clear understanding of the upstream and downstream dependencies among all the various workloads in their data center. And then when a change occurs in the data center, when they upgrade an application or an application goes down, they have unintended effects from that. And the reason they didn't anticipate that particular failure or impact is because they didn't have a clear understanding of the upstream downstream dependencies. So you're kind of doing yourself a favor with step 2 anyway, and in that you can build a great deal of documentation around how your environment looks and how they're all the workloads are related to each other, and which workloads are user facing and which workloads are not, which ones are externally facing to your business partners or customers and which ones are not, and then you can begin to work from there. So I hope that satisfies their question on disaster recovery. Another question here, about a question on the exam. I don't know if it's a question on the exam or not, but whether it is or it isn't, it certainly should be something that you should be prepared to address. So, great questions. Now let's move into a discussion on some common design misconceptions. And what I want to present here are just some things that I see or run into as I talk to people, as I talk to customers who are implementing VMware vSphere. What are some common sort of thought processes and that sort of thing that we run into? So the first one, I'm a vSphere expert. I don't need to be an expert in blank. And in blank, you can insert storage or networking or security or operating systems or end user support, whatever. Insert technology here. The problem with this design misconception is that if we accept that a VMware vSphere design is inherently comprised of multiple different systems, and that those systems are interconnected and interrelated with one another, then we then have to come to the conclusion that while we don't necessarily have to be an expert in blank, we certainly need to be, I guess I would say, proficient or well-versed in the basics of whatever technology we're talking about here. And this is one of the reasons why I feel it's critically important for any sort of person who's going to take on the role of a vSphere architect and be designing vSphere environments, that you are familiar with all of the different components that are involved in a vSphere design, not just vSphere itself. And yes, it's absolutely important to be very, very proficient in vSphere. No question about that, right? But we also need to know enough about networking that we can understand if the networking group submits a non-functional requirement or a constraint to say that the networking has to be configured in a certain way. We need to know enough to be able to understand what impact that constraint is going to have on our design. And if we don't at least know the basics in networking, then we're going to be unable to elaborate or to expand upon or understand what the relationships and the impacts are going to be. We're not going to be able to adequately account for what that's going to look like or what that's going to do. So I strongly recommend to everyone who is going to take on the role of designing a vSphere environment that you make yourself and make the time to become at least reasonably well-versed in key areas of vSphere design, not just vSphere itself, and you absolutely need to make sure that you understand the hypervisor and the platforms and all the components that come out are included in vSphere, but also networking, storage, operating systems, security. All of these are going to play a role, and because of the holistic nature and the holistic view that we want to take as we create the design, this is definitely going to make you a better vSphere architect and better able to understand all the relationships and dependencies that exist. So we've had a few other questions come in here. One question about document templates. So there are some document templates that are out there. I think that if you are a VMware partner, VMware provides some documentation templates to their partners as part of the partner program. Beyond that, there, I believe, are some documents. There is a document actually that I share in the Designing VMware Infrastructure course that is published by VMware and is considered a reasonable template for looking at designs, because it lays out the design factors and the impacts and then goes into a logical design and then from there into a physical design. So that might be one to consider as well. Let's see, another question here about backup to tape being required or disk-to-disk backups. This is really a question that should be driven by the functional requirements of the organization. So you have to look at what your RPO and RTOs are. You have to look at what your backup windows are. You have to look at how much data you're backing up, and you really have to make a decision from there. Some organizations will be well served by backups to tape because their backup windows and their data recovery needs can be satisfied by that in a cost-effective fashion. Other organizations may need disk-to-disk backups. So that's really a question of what your operational requirements are. Another question here on the role of the hypervisor. So that's something you'll definitely want to make sure that you understand the role of hypervisor in a vSphere environment. If you are unfamiliar with what the role of the hypervisor is, I would recommend you take a look at some of the VCP5 type training. That'll give you an introduction to what a hypervisor is and what role it plays in a broader vSphere implementation. Question here about testing for projected workloads. So what you have to do here is you have to do some extrapolation. It's unlikely that you'll be able to spin up the 500 VMs that you think your organization is going to need, 3 years from now. You can do some baseline testing, and then from there you can begin to extrapolate on if I run my current workloads and I'm at X% utilization, or if I run a subset of my current workloads and I'm at X% utilization, then from there I can begin to extrapolate out what it's going to look like when that workload doubles or when it triples or when it quadruples, depending on how much growth you're going to do there. And there are also some tools that you can use that will help provide some trending analysis that will help you get to that point. So you can use some performance testing tools, Iometer and others as well if you're interested. Try and put some load on the system. Standards of templates for designs. I mentioned this earlier. VMware partners have access to some VMware supplied templates, but other than that, the only documents that are required are just to describe in some sort of comprehensive fashion what the design looks like. So moving back to our common design misconceptions. If you're not an expert, you can't be an expert in all things, okay? But you do want to make sure that you're proficient in as many different areas as possible so that you can understand the relationships between all the different areas and can elaborate on what the impact will be of a change in one area on another area. All right, here's another one that I've heard said, surprisingly enough. I don't need to assess my workloads. I'll just change things after the design is built. Now, I will say that one of the great things about VMware vSphere is that it is a very fluid technology. And what I mean by that is that there aren't too many things that you do in a vSphere design that you can't change later on, if necessary, depending on how your workloads shift and how things change. If you start out with a certain cluster size and then later on you realize I need a different cluster size, no problem. We can move workloads around using vMotion. We can take hosts out of the cluster. We can add hosts to the cluster. Not a big deal. If you decide you initially want DRS configured one way and then you want to change it to another way, generally not a big deal. Now, you will run into some things that might cause a bit of an interruption in service or a bit of frustration as you change those. One that jumps to mind would be something like enhanced vMotion compatibility, in that if you don't set that when you first create the cluster and then you want to go set it later on, you'll have to take an outage to some of your VMs in order to fix that. But it's not the end of the world. If you need to change something, it's not the end of the world. However, I don't go so far as to say that I agree with the statement that I don't need to assess my workloads. Because if you're trying to build a design to satisfy some sort of functional requirement, maybe you're migrating your non-virtualized data center onto VMware vSphere 5, and you're going to take advantage of all the benefits that vSphere offers, vMotion and maintenance mode and all the cool stuff. How are you going to go about building the design if you have no idea what the design needs to do? It's like shooting at a target and you don't know where the target is or what the target looks like. You have to have some idea of what you're shooting for. So I absolutely think that workload assessment and knowing your current environment, I alluded to this earlier, that you have to have a deep and thorough knowledge of your current environment, whether that be projected workloads you're going to put on there, or whether that be new workloads that you're going, or projected workloads, or whether that's going to be existing workloads you're going to migrate over. You have to have some idea of what those look like so that you can then begin to shape the design to be able to satisfy the functional requirements of those workloads. So don't think that you can get away without assessing your environment in some way. And there are lots of ways to assess the environment. It can be as simple as collecting some performance counters using operating system specific tools, or it could be as complex as running some third-party tools that not only bring technological data into it, but also help you build stuff like business rules, which business units own which units and where they're going to have to reside. It can get really complex, or you can make it simple, but you need to have some sort of idea of what's involved. Here's one that I've run into before. I'll just plan on provisioning my VMs the same way I provision my physical systems. Well, when I hear somebody talk about provisioning VMs and they're kind of doing things the same way they did them before, the thing that always pops in my mind is a statement which I believe is attributed to Albert Einstein, and that is, we can't fix problems using the same thinking that we used to create them. And if you're going to continue provisioning your VMs from a resources perspective, from a process perspective, the same way you provision physical systems, the only thing that you've done is virtualize things. And you haven't really begun to take advantage of what vSphere can offer to you in terms of efficiency of operations or efficiency of resource utilization. I'll share a story with you, and I'll change the names to protect the innocent, but I had some years ago a customer who provisioned their VMs in the same way that they provision physical systems, and that was basically they gave them way more resources than they actually needed. Multiple virtual CPUs, lots and lots of RAM. And then they were surprised when their environment didn't scale as far as they thought it would. And the end result after coming in and doing some analysis is that they were just grossly over-provisioning resources to VMs that had no need whatsoever of using those VMs, giving way more virtual CPUs than what were required, and way more RAM than what the workloads were running, because that's what they'd always done in the physical world. And in the physical world, you needed to do that because that was the only way to respond to any sort of spike in utilization or anything of that nature. We had to make sure the resources were there just in case the systems needed it. Now we can allocate resources dynamically. In many cases, we can do that even without having to take the workloads down. So it's important that you understand that you don't want to do things just the same way that you've always done them. Make sure that you look at your operational processes and procedures as you implement VMware vSphere, and then streamline your operations and streamline your allocation procedures to really take advantage of what VMware vSphere can do for your environment. That'll help you get the most out of the environment that you can possibly get. All right, so here's another one. I'm going to place VMs on the storage based strictly on available data store capacity. I'm going to look in the vSphere client, and I'm going to throw a VM on this data store because it shows that it has 500 gigs free, and this other data store here only has 350 gigs free. What you're doing there when you do that, and when you build the design and you ignore a key dimension of the design, you are opening yourself up to real problems. In this case, what we're ignoring here is we're ignoring the dimension of storage performance, such as IOPS and latency, in that we're only measuring performance based on one dimension, and that's capacity. And that would be the same as us measuring our compute performance based solely on CPU utilization. Well, what about memory utilization? What about network utilization? You know, those are other very valid metrics that we have to be sure to account for when we design and place VMs into the place workloads into the environment. By the same token, here you have to make sure that you understand, and this is kind of goes back to my first design misconception about not being an expert in other areas. And you have to make sure that you understand the basics of how stuff like storage works. You know, yeah, there's free capacity there, but is that data store and the disks that are backing that data store, is it capable of providing the necessary performance requirements that that workload has? If I take you know, some sort of transactional workload like a database, and I put it onto a data store without an idea of what the IOPS are going to be that that data store requires, what the latency measurements are that the data store needs, I might inadvertently put myself in a situation where I have a business critical workload that is end user facing and is core to part of the business processes in my organization, and now it's not going to perform the way it needs to perform because I've inadvertently overlooked a key dimension in determining how things happen. So make sure that you understand not just capacity, but also the underpinnings of what things happen. So, you know, talk to your storage folks, talk to your networking folks, talk to your security folks if those folks aren't you, right? Or if you are one of those folks, talk to the other teams. You know, more collaboration when you are responsible for one area and you have dedicated teams responsible for other areas is only going to bring about a better implementation, because you're going to be able to share and collaborate and understand where the other one's coming from and be able to get a more complete and comprehensive view of the design. So before I move on to this discussion of certification, let's quick look at the list of questions that have come in. So the networking design, should the VMware design point to or reference areas of networking or storage that VMware plugs into? Should it include zoning details or how network ports are configured? That's a great question. My personal view is that the VMware design should include everything. It should include relevant zoning details, relevant vSAN configuration details, relevant VLAN configuration details, port configurations, switch redundancy configurations, firewall configurations, where those are applicable to the vSphere environment. Now, you know, if we've got a firewall rule that is controlling traffic going to some Unix system that is not at all involved in the virtualized space, you know, okay, yeah, we don't really need to include that, right? So if there's a clear separation that it's not going to have an impact on the vSphere design, I could see leaving that out. But anything that could have an impact on the vSphere design, I believe needs to be included in the VMware design. Now that does make the documentation bigger and more complicated, but I think it's important. All right, so how important in the design is it to justify decisions you make, or okay, just to document the solution and your decisions that are taken? I think that it's important that every decision that you make in the design should be backed by some reason, some valid justification. Now that can be as simple as a functional requirement says that I have to have an RPO or an RTO of X. Okay, and this is how I went about implementing that functional requirement. It could be as simple as you have a non-functional requirement or a constraint that says I must use vendor X for my networking solution. Okay, this is how I go about doing that. In other cases, there might be more than one way to satisfy that, and where you can justify that with some valid reason, whether it be cost savings or you know, it's a better fit in the operational perspectives of the organization. You know, think about things like if your organization is currently using rack-mounted servers, and then from vendor X, and then you recommend that this new environment go to blade servers from vendor Y, Well, there's an impact there, not just a technological impact, but an operational impact. You know, that new server platform is going to be managed very, very differently than the way you manage your current server platform. And there's different tools and different applications and different vendor support structures. So all of these things have to be taken into account. And you have to make sure that you can explain the decision where all other things are equal. You know, if there's no budgetary impact and no operational impact and no technical impact that is, you know, has any sort of significance, then it comes down to, honestly, it comes down to personal preference. How did you, as the architect, design it? Provide some explanation and then move on from there. All right. Would I advise, where possible, designing a repeatable, flexible design or a design for each solution? So wherever possible, you want to be able to build repeatable solutions, but you have to understand that there's only some level of repeatability that you will be able to replicate among multiple environments. You know, depending on what level you talk about this, you know, I could say, well, every vSphere design is repeatable because it all uses vSphere. Yeah, that's really, really high level. But, you know, we have, because there's so many factors that come into this, because it's not just technological, you know, I need X number of cores and X gigabytes of RAM and X terabytes of storage and X thousands of IOPS, but there's also organizational operation, there's organizational aspects like which part of the organization is responsible for which task, who runs backups, who does OS support. Is it the Unix team that owns vSphere, or is it the Windows team that owns vSphere? You know, simple things like that. Those are going to have an impact. And so a simple repeatable design may not be achievable in every single aspect, but I think that there are places where you can leverage some recommended practices and build some modularity so that you're not constantly reinventing the wheel. However, in every case, you do need to make sure that you are satisfying the requirements and the constraints and mitigating risks, and those will be unique, generally speaking, to every single environment. All right, question here, how do we design how much bandwidth per client we have to calculate? Well, without knowing exactly what workload we're talking about here, there's a variety of operating system specific tools that can help you get network utilization, both from a client perspective as well as from a server workload perspective. You could also use network analysis tools like NetFlow or others to be looking at information that's traversing the network, and that might give you an idea of what's going on as well. And when we assess workloads, how much headroom do we need to account for? Taking out the fact that you need to add for growth. Well, so this, in my mind, is kind of the question of, do we plan for the average or do we plan for the peak? And that's the way I would rephrase this question is, if you plan for the average, then and then you go up to utilization, to a certain percentage utilization, then you're potentially cutting off the peaks, and you could run into a situation where you don't have enough capacity when you hit a peak usage. So there are some assessment tools that let you look at not the average utilization, but the average peak utilization. In other words, when we look at those spikes in utilization that occur at certain times of the day and certain days of the week and certain weeks of the month and certain times of the year, depending on how long you run your assessment, then we can begin to look at the peak average and then begin to plan from there. But generally speaking, whenever you lay the design out, and this has been laid out in a number of venues, you will say, I'm going to run the assessment. I'm going to come up with, let's say, I'll pick a number, 20,000 megahertz of CPU capacity required. Okay, or you know, all right, great. So I need 20 gigahertz of CPU capacity. Then you're going to look at your server platform and say, okay, my servers are capable of providing a certain number of gigahertz, so I knew I need X number of servers. You're generally going to say, I'm going to drive the servers up to something like 75 to 80% utilization. And that gives you the headroom for those peaks that move beyond that. That will depend on a great number of factors. It'll depend on your budgetary constraints and that sort of thing. But generally looking at 80% utilization from CPU RAM and maybe something a little lower on the storage, depends on your storage platform, what you're trying to accomplish, would be reasonable amount of headroom to leave. When we're doing storage, we want to size LUNs per VM as a very, very large LUN and put multiple VMs in it. Well, like all other things, this is going to be shaped by our functional requirements. So there is no single answer that I can provide to that question. and that's a fancy way of saying it depends. But the deeper details on that is if you have workloads that specify certain RPOs or RTOs, and maybe you're using array-based replication or something else of that nature, it may come down to you're going to have some workloads that are on their own data stores, and those data stores are on their own LUNs because of replication consistency concerns or disaster recovery, backup, whatever the case may be. And then there may be other situations in the same environment where you're going to have a larger LUN, and that larger could be, whatever you consider larger. Could be 1 terabyte, could be 500 gigs, whatever you consider larger. And you're going to have multiple VMs in that because those VMs might share a common RPO, RTO. They may not require, backups or snapshots or anything of that nature. So it's really going to be driven by the functional requirements in your environment, and then you can craft an appropriate architecture to take care of that. All right, I'm going to go ahead and talk about the certification thing. I know we have a few more questions that are still pending, but I'll come back to those in just a moment. So we've looked at the basics of vSphere design. What is design? What does that mean in the context of designing VMware vSphere environments? We've then looked at the basics of design, kind of the 5 high-level steps. Know your design factors, know your current workloads, design your environment, but you always maintain the holistic view, test your environment, and document everything, right? And then we looked at the misconceptions. We don't want to make sure that we're focusing only on one area. We want to be well-versed in all areas so we can understand the impacts of design decisions. Make sure that we look at all the different dimensions of the various components, not just looking at things from a capacity perspective, but also from a performance perspective. Now, the question then becomes, okay, so I'm responsible for vSphere design, and all of your information there is very useful, and that's great. But should I be pursuing certification, right? Or another way of asking that is the VCAP DCD exam, which is the VMware Certified Advanced Professional Data Center Design. Is that exam right for me? Now, the important thing to understand is that it's a follow-on to VCP. So if you haven't already gone through and done your VMware Certified Professional or VCP, you'll want to do that first, and that will give you that base knowledge in vSphere that you really have to have. Although I did say that you need to be well-versed in a lot of different technologies, you need to make sure that you are especially well-versed and especially proficient with the vSphere products itself. So once you've gotten your VCP down, then ask yourself these questions. Are you someone who is responsible for designing vSphere or VMware environments? In your role with a partner or a reseller, is that what you do for customers? In your role as in an organization, is that what you do for your own organization? Are you seeking a broader, more systems-oriented approach? And this is another way of saying, are you looking at being able to look at things and view things and handle things in a more holistic fashion? Are you pursuing VMware Certified Design Expert or VCDX? If you answered yes to any of those 3 questions, then I think that VCAP DCD is something that would be a good fit for you. If you are responsible for designing VMware environments, then the process of being prepared to pass the VCAP DCD exam is going to help you, in my opinion, be better prepared to design VMware environments both for your own organization or for customers. If you're seeking a broader, more systems-oriented approach, then having to maintain a holistic view as you prepare for the VCAP DCD and understanding that there are relationships and dependencies and impacts as one thing change, that's going to help you have a broader, more systems-oriented approach to the environment. And of course, if you're pursuing VCDX, then VCAP DCD is a required prerequisite. It's probably redundant. It is a prerequisite for VCDX, so you must pass VCAP DCD as well as its sister exam, VCAP DCA or Data Center Administration, in order to proceed on to attempting to achieve VMware Certified Design Expert. Now, the Designing VMware Infrastructure video training series that I recently produced with TrainSignal and is now available is intended to help you prepare for the VCAP DCD exam and would be one of a number of different components that would help you be prepared for that exam. All right. So let's take a look at some more questions here. See if I can figure out where I left off. All right. After implementation completed and signed off, how often do you recommend a design be reviewed? That is, again, going to be driven by the functional requirements. And it's also going to be driven by kind of the operational, the way that particular organization runs its operations. Some organizations will put in the design and they will run it, and the underlying design is like a frame. It stays there. You may grow it, right, by adding pieces onto it. It's where you want to make sure that you build a modular framework to allow that to grow and be flexible in that. But they don't really go back and review the underlying design until it's time to migrate to a new version, migrate to a different hardware platform, migrate to a new data center, and there's some major thing that we have to change. So that might be one of it. Other organizations will review the design on a more regular basis and will recommend changes. So it's really going to be driven by the operational aspects of the organization and whether they view design as an operational piece or more as an architectural piece. And I can't really give you a strong answer. If you view design as an operational piece, then it's just going to be driven by, you know, how often your organization, how fast your organization is growing, how often is it changing, you know, can it sustain having a longer cycle, which would be less work, but can the business continue to do what it needs to do on that longer cycle? And just don't know without knowing the organizations better. All right, examples of tools for peak usage. I know that the VMware Capacity Planner tool, which is VMware's hosted workload assessment tool, will give you the peak average in addition to just the average to allow you to plan for peak average as you look at consolidating workloads together. That's one, and there are a number of other third-party tools, PlateSpin, Serva, others that do workload assessment and then give you projections of what it's going to look like when you consolidate those onto your virtualized environment. Minimum requirements to run vSphere. You need a 64-bit processor. I think you need a minimum of 2 gigs of RAM, although I'd really recommend you do way more than that. Some storage and supported networking. That's all pretty well documented publicly, so I would refer probably to VMware's website at the official vSphere documentation for minimum requirements. To get VCP, you still have to take VMware certified training. Yes, you do. You still have to sit through VMware's training course in order to get your VCP. Once you have gotten your VCP, then the training courses are not required, but you do have to take the course in order to get your VCP. You can take the exam before you take the course, but you won't get officially certified until you take the course and the exam. Can you go from a VCP 4 to a VCAP 5, or do you need first upgrade certification to VCP 5? I believe, although I'm not, I wouldn't consider myself an expert on VMware's specific certification requirements, I believe you're going to need to upgrade your VCP to VCP 5 and then proceed forward from there, but don't quote me on that one. So I would recommend you check out the VMware certification website and look at their workflows to see exactly what's required there. So we have someone who is responsible for doing backups, designing DR. They want to know, will it help to pursue doing VCAP DCD? That's a decision that you probably have to make on your own. Again, I'll go back to the questions that I asked earlier, and that is, are you responsible for architecting VMware environments? Are you looking for a broader systems-oriented approach? Or are you pursuing VCDX? If any of those questions can be answered yes, then pursuing VCAP DCD, I think, would be a help. If you honestly answer no to all three of those questions, then you might want to do it for your own personal benefit, but I don't know that it's going to be a whole lot of benefit other than that. Somebody here considering doing VCAP DCA, and it asks, is one more valuable than the other? And I assume the question is DCD versus DCA more valuable? Again, I'll reiterate, if your job role involves answering yes to any of the three questions I described earlier, in that you are responsible for architecting environments, or you're looking for a broader systems-oriented approach, or you're pursuing VCDX, then DCD is going to help. If you answer no to those, but you are responsible for managing and operating a vSphere environment, then DCA is the in-depth data center administration exam, and I think would provide a great deal of benefit for you. Both are required if you want to proceed on to VCDX. But the exams are split there because there are some people who will administer environments but aren't responsible for the architecture of those environments, and may not even care about the architecture environment. They're just managing them. That's VCAP VCA. And you have others who architect the environment but may not manage them, and that's more targeted by VCAP VCD. Tools to do the initial assessment. We want to move a workload, but we can't tell you what the workload is because we don't have a good handle on what's on the environment. I alluded to a couple of these earlier. VMware has a tool called Capacity Planner, which is a hosted tool that will do the assessment for you, gather information, and then gather all that into a database and do some analysis for you. There are also third-party tools. I believe PlateSpin still offers one. There was a company called Serba that offered one as well. And there may be additional pieces as well. Depending on the complexity of your environment and the size of your environment, you might even be able to go to any sort of configuration management or change management tools or inventory management tools to get an idea of what's in your environment as well. But that would involve a little more manual collation and manual putting data together than perhaps one of the tools that are specifically designed towards assessing environments. Good tools, general business analysis frameworks. Not any that I am immediately aware of. I'm sure that there probably are tools out there, but nothing that I am immediately familiar with, so nothing there. We're coming up on just a few minutes left here, so let me try and finish up some of these questions and then wrap up the webinar. So a question here about looking at VCP5 or VCP5 infrastructure as a service or both. Again, this is going to be something that is really driven by your own organization and your own career goals. The VCP5 infrastructure as a service exam is more when you are looking at things involving vCloud Director and infrastructure as a service, a more automated, dare we say, cloud-focused approach. Not just virtualization, but also all of the other pieces that involve that, so more automation, more orchestration, more self-service, et cetera, et cetera. That's more the VCP5 infrastructure as a service exam. VCP5 is strictly focused on vSphere, so you'll have to decide which way you want to handle that. You know, it's really what's best for you as an individual, both on your own personal growth as well as where you fit into your organization, what your organization needs. With reference to design, do we recommend converged networks, and specifically multiple security zones like DMZ and production hosted on the same ESXi host? That is a question that is best answered by looking at your organizations or your customers' security policies. Do their security policies permit that to happen? If you go back and review things like the PCI DSS virtualization guidelines, they will provide some guidelines on how multiple security zones, such as PCI compliant and non-PCI compliant workloads, how those can and should or cannot and should not be combined based on those recommendations. So that's something you'll have to look at. There are no known security risks with a properly architected multi-security zone design, but again, this is a question that you'll have to discuss with your own organization or with your customers. Make sure they understand the risks and the benefits. Look at what their requirements are and their tolerance for risk is, and then you can make a decision from there. All right, so that's all the questions I have at the moment. Let's just recap what we talked about real quick. We first started out with the basics, or what is vSphere design? We looked at the definition of design being to determine the functioning or the appearance of something, and we applied that to VMware vSphere environments, knowing that we need to create the function of a VMware vSphere environment within its own, wherever you're putting it, the function is going to be what it needs to do. From there, we looked at the basics of design. I provided you some high-level steps of what you need to do in a design process. Know your design factors, risks, requirements, constraints, and assumptions. Know your current environment. Design the environment, but always maintain a holistic view. Test it and document it. Right? Then we looked at some common design misconceptions, certain ways of thinking that we don't want to get locked into, else we run the risk of our design not being as comprehensive as we need it to be. And then finally, we had a discussion on whether the VCAP DCD exam is right for us. And that concludes my content. Let's see if we have any other questions we need to address. There are no other questions listed at this time. So, Chris, if you want to pick it back up from here, and we'll open up to other questions.
That's all the time we have today. Thanks again, everyone, for attending and for all the participation and great questions for Scott. As a reminder, today's webinar was recorded and will be available to view at trainsignal.com/blog/webinars. We will also email you the link by the end of this week. And remember, as you leave, please fill out the survey for a chance to win a copy of Scott's course, Designing VMware Infrastructure. We will email the winner by the end of the week also. Thanks again, everyone, and have a great day.